Hi everyone, welcome back to this YouTube channel, Frowning Upon Mathematics. In this clip, we are going to test some figures, whether some figures on your screen are similar or not. But before we do that, don't forget to subscribe and comment on the clips. Okay, so two figures are similar when all interior angles are equal and the ratio of all sides lengths are constant. Yeah, so we're going to rely on those principles throughout this clip. Okay, so on our screen there are two triangles and it is given that they are similar figures. One thing that we can focus on will be uh, this is the acute, this is the obtuse, and another acute angle. Okay, so this is the obtuse, this is the only obtuse angle that we can see, and this is the one as well. So we have this idea that this is the obtuse, and we can see that this one is kind of shorter. Yeah, so this should be QR. BC is going to be, RQ is scaled down version of BC. So that means here is also PQR, QPR, my mistake. So BAC is equal to QPR, which is X, which is 30 degree. Again, we have to observe things closely, and then we can check it on the adjacent line. Adjacent means the next neighbor line, to check whether it's going to be the one that corresponding to the other or not. That's how I work on these kind of questions. Okay, so we have our x. And now we are going to work on this one. The ratio of all sides length are constants. We need to find y. So here we know that 6 will be compared to 4. So that means y will be compared to 2.8. Again, I'm comparing that I locked my left to the right triangles. Yeah, that needs to be constant from the beginning. So once again, AC over PQ equals to BC over QR. That's why I plotted over here. I substituted that with the data that I have, and I have y equals to 4.2 centimeter at the end. Don't forget to cross cancel this part as part of your algebra's understanding. Okay, so we are going to move on to the next figure, which are quadrilaterals. Now, here again, first thing that I will do will be observing which part that I'm going to focus more. And also in this page, it is given that these two quadrilaterals are similar. So after observing for a while, I know for sure that AB should be compared with PQ, right? Because I will call this one as my top and this one as my base. Here, this is flipped. This is flipped and it's kind of shrink to this size. So 4 became 3. Yeah, we don't have to work on DC and RS. Okay, but here we realize that 100 degrees is supposed to be this one, because when we flip that up again, 100 degrees will be over there. And then we know that this one is the pointed one. Yeah, so this will be 60 degrees. That means the opposing will be 100 degrees. So we're going to write that one first before we forget. So we know that W, okay, is that W will be 60 degree, and x will be 100 degree. Okay, right, we're going to put our answer over there. Okay, and then here, we know that this one is going to be our comparison, our first ratio, 4 out of 3. So that means this one will be compared to Z. AB over PQ equals to AD over PS. 4 over 3 equals to 6 over Z. Z will be 4.5 centimeter. I have my note next to me, so that's why I can check it again anytime I'm in doubt. Okay, so 4.5 centimeter. So that means the only thing that we need to check is now the y. Obviously, we can compare it to this one then. yn 5.4. Okay, so using the same thing, I'm going to just copy this one. Okay, and I'm going to put it over here now. All right. Okay, so AB over PQ will be, okay, AB over PQ will be BC over RQ. BC over RQ. And it will be 4 out of 3 equals y over 5.3, 5.4. So that means my y will be 7.2 centimeter. Okay, right, so I think we can have a break on this part, but you studied how to deal with the quadrilateral and then the triangle for the applying the similar figures concept, and then finding that with the unknown data. So I will stop here and we can continue to the next clip.